Okay. Hello everyone. So now today, we are going to discuss a solution for a Google Kickstart Round F. Second problem. Mostly I have pasted a first problem already in my YouTube channel. So just go and check it. I can add those description link in the description also. So we'll enter this into this problem. So this problem is basically on data structures, purely on data structures. The problem contains like a water container system with an analytical containers. Uh, it can be represented as a tree, so where each container is a vertex in the container are combined with each of a bioanalytical level. So two containers which are always placed in adjacent levels. Only if two containers A and B are connected to each other, then A minus B level equal to 1. So container one is placed in the bottommost level. Each container is considered exactly. So just note this case, container one is placed at the bottom level. So all initially, you can there is no need of representing. Just say we have a root container that is 5, so it cannot be occurred. So root container is always 1. So you can be damn sure those kind of things. So initially, container will be formally from 1, 2, 3, something like that. So it is up to a lattice case or something. So which has a no connection below it. So make sure that maximum capacity of each container is empty. So initially all the containers are empty. So as in that 0 liters of first level of container. So okay, they will be giving Q queries, that is something called liters. So far I represent. So you need to pour of water in that container, that given queries container. So what it is now, in first step, they are giving a query for 3 things, and then in that 3, if you drop a 1 liter of water in 3, so it will automatically go down to the inverted tree called this container 1, and then you pour water to this 4, and then this 4 will go into this 2, and then it will be equally spreaded with the 3. So that's what happens. And then you again pour a water in 4, and then equally splitted half will become a full, and then you again enter a liter in this 3 itself. So what will happen, it will go up and fill this container 4. So there is, in this case, there is no need of finding depth of the 3. And what we need to do there is no need of this query values, or where is the problem in these cases. So there is no need of these query values, so which is presented here like this. So which is presented here. So there is only value for this node adjacent, placing, and then this total number of liters that is passed into that container. So whatever we have, we will we will drop it from the top, that is this leaf container. So what we'll do now, we will discuss it with this type of problem. So we what we'll do, we will create a graph. We'll create a graph using a dictionary. So this is formally we are creating a graph using a dictionary, and then what we'll do, we'll literally this. They are saying it is a purely a binary tree, so which means you can also use this binary tree, implement this binary tree in graph also. So for me, it just be easy when it comes to binary graph or something. So we'll have this value something in different. So always this value would be 1, and it's 2, 3. Let's assume in this case, okay. So what will do now? It'll normally we will be having something called so for given a query, right? So we'll take something called a 7 liters or something. Okay, 1, 2, 3, 4, 5, 6, 7. So we are having like about 6 liters. Let's say round up it. Okay, so we'll have it 1, 2, 3, 4, 5. Okay, we'll have it about 5 liters. Okay, so what we'll do, we will formally like get a drop. We will pour this here itself. Okay, so if, even we will have a 1 liter or something, even irrespective of the query push with query container. So we will always place into this 4 container. So what we'll do, it will go down and fill this first container fully. So this first container will be like full, and then one is finished. So 4 will be remaining. So even though it will half will be full, so it fills the half for the second liter, and then the another half for the third liter, and then for fourth liter it will fill in for quarter. Each and everything will be like quarterly based. So for the fifth liter, everything will be like becoming half. So in this case, like what we are like half is empty here, right? So how much we need to find in this case, like we need to find number of containers that are fully filled in a particular level. So we'll go from this bottom here, like this bottom of the tree. So this container is full. So level 1 is like level 0 is fully filled, and then we'll go to this level 1. Level 1, it is also full. So this container is 2 nodes that are fully full, which we have in the level 2. We have 4 nodes, sorry, 4 nodes, but none of them are full. So what we'll do, we'll go to this case here. So we will have something called lands here. So we'll find this total number of nodes which are present in each level. So this lands will return this kind of array. So this lands will give a array called so which will return each number of nodes that are present in each level. So okay. And then what we'll do, we'll compare with this land f. So that is query that we have, right? So we got initially. So what we'll do, we won't even use this query list. Okay, so that is something called empty or something we won't use. So what we'll do, we will go through this every I. So for I in lands, right? So first 0, that is container 1, that is first level. So if I is less than or equal to f, answer plus equal to 1, I, that is first container. So number of containers filled, right? So I will give a so answer will be like 1, and then f minus equal to I. So we need to minus that container from this query, right? Number of liters that has to be minus, right? So if this condition fails, right, so we'll return the answer. So that's what happened. That is what's happening here. So you can also use a graph with DFS. So I'm not sure, like many have been using this and have used a graph that is with data structures. I mean, sorry, DQs or something, dictionaries. So thanks for watching my video.